I hope my screen is visible now. So just a slight introduction of myself first. I'm currently working as a machine learning engineer at REDBUFFER, which is an AI-based services company. At the same time, I'm also a Google developer expert in machine learning, which in summary means that I work to basically build the community around me. I give workshops, I give talks, I write blogs, and they're all more or less related to machine learning. So today's session is briefly on TensorFlow and a couple of other things that you can do very easily in CoLab. And CoLab, so I'll start by one of the interesting things with CoLabs is that you can very easily integrate it with Kaggle as well. And Kaggle is like the data hub of everything ML these days. There are a few steps that you follow. So you basically install Kaggle library. You have to make like a few files in order to host your key from your Kaggle account. So you do that. You make the JSON file. You set a few settings that are required, and then you're set to access anything as if you're right in your Kaggle account, right? You can list down the data sets that are available in Kaggle. So these are all the data sets. There's a longer list, so you can list down a subset of that. You can also maybe identify and say, okay, I just want to see the sentiment data analysis available on Kaggle. And then once all of that is done, you can just use your key and you can download any data set from Kaggle directly. So for example, here's a simple example of how I wanted to download a data set for which had images of malaria cells, so infected and uninfected malaria cells. And this is how I could easily just download that. So I get that right here in my CoLab files directory. And I can simply unzip the data. So I wouldn't go too much into the details of how the code exactly is working, but just to give an idea of the some of the amazing things that you can do right here in CoLab, right? So you can unzip the data, you can create directories as you like, and all of those are visible right here to you. And how? So here you can see that I have all the directories here of testing, training, uninfected, whatever kind of directory setting that I want. And here's a little into how the dataset basically looks like. So this is what the dataset looks like. So you have infected images, you have a few uninfected images with no spots at all. And one interesting thing that I can do directly here is connect my CoLab to my Google Drive. This is taking a bit of a time, but I'll tell you what this initially does. It basically asks you for authentication. Once this has run completely, it'll ask you for authentication and basically ask for a code that you'll get through your Gmail account. You enter that here, and then you're connected to your drive. What that basically means is that you have your drive mounted right here. So if you can see, here's my drive, and I sort of also has some of the folders from my drive right here. And then you can save. You can also pick up data from your drive. You can save models to your drive, especially when you want to save, for example, checkpoints of your models, or you want to pick up a saved model and try that out. And it also helps in ways where you want to share that model with other people. So you can play as much as you want in the CoLab, save that to drive, share that drive link with someone else, and they can load it in their own CoLab, etc. The model that is built is simple. It's just a few layers of convolutional neural networks, maxpool layers, layers, etc. But the point essentially, here's a small summary. So it's not a very complex model, but here's a summary of what it is. The number of total parameters, and there are about like 13,000 images per class, so 13,000 for uninfected and 13,000 of infected cell images. So once I have sort of like built the model, I can also use TensorFlow's Tensorboard in order to evaluate my model performance. And that's pretty simple as well. It's just like 3 cells here. So you load Tensorboard. All you have to do is basically create a callback for your Tensorboard. And the callbacks in TensorFlow are basically what they refer to is you sending feedback, data feedback to a service in TensorFlow, right? So you can have Tensorboard callbacks. You can also have early stopping callbacks. So early stopping callbacks would be if you want to, for example, stop your model after it has reached 90% accuracy or after the loss has reduced to 0.1, things like those. And this is a classification for whoever asked that. So this is a simple classification model, and you're classifying images into uninfected or infected cells, malaria cells, right? So what you do is you create a Tensorboard callback, and you pass that to your fitting function, right? And you can have a number of callbacks at one time as well. So you could have TensorFlow callback as well. You could have early stopping callback as well, and you could have a few other callbacks as well. You can also save your checkpoints, and you can have like a checkpoint callback as well. Okay, I want to save my model in my drive after every 5 epochs. So we already have a drive mounted, right? And if I want to create a checkpoint callback, this is what I'm going to do. So I'm going to define exactly where I want my checkpoints to be saved in the drive. So that's drive, app, malaria detection, the folder that I have in my drive, right? And I'm going to create a callback again. And then here, the callback that I'm creating is model checkpoint. So I can sort of define, okay, I only want to save the weights. I don't want to save the entire model. Or I want to save it after every 3 epochs. So you can define the period as well. Or you could make it 5, or you could make it 10, depending on the sort of model you're building and basically depending on the complexity of the model as well. So these are hyperparameters that you're basically deciding yourself. So if I want both checkpoint callbacks and Tensorboard callbacks, so I'm basically just going to add another CP callback here as well. So it's going to call both, send data feedback to both of these services basically as it is training. So as your epochs are basically running, this is how, so you can write a small command to basically see how your Tensorboard looks like. And this is how it would look like. And you can see that it has displayed both loss, epoch loss, and epoch accuracy for me. The accuracy is increasing for each of these data points basically refer to one epoch, which is one training step over the entire data set. So you can see that it started off here. And it's also displaying when I ran this model, and with time, the accuracy is increasing. And then finally, this is where I am. And similarly for loss, you can see the loss as well. And there are a few other things as well that come with Tensorboard. So you can also see your model here, like the entire look of your model, what it looks like. So there are dense layers, flattened layers, max pool, etc. At the same time, you can then save your models to your drive as well. You can directly do model.save as well, but I made like a small function because I was saving both checkpoints and the model. So I made one function up here, here. So this was saving both my weights and my model. And this is one bit of like a few bits of what you can do in Google CoLab. Now, one interesting thing that I want to share in the little time I have is with respect to explainable AI. So I introduced that like a tiny bit. And if you find it interesting, please go back and definitely look deeper into this. So so initially, over the past few years, we have seen that there has been like a change from heuristic and rules rule-based machine learning to linear models, deep models, and then meta learning. Meta learning is where you have a model that's creating another machine model, right? And with time, we've also seen that as the complexity has increased, it has sort of like become harder for us to understand what the models are doing and why they're doing what they're doing, right? Something that is more commonly being referred to as a black box now, right? So explainable AI is basically the process of understanding how and why a machine learning model is making the predictions that it's making. So for example, if I'm sending in an image of a malaria cell and the model says, okay, this is infected, then how can I understand why is the model calling this infected? What is the model looking at, and how is the model looking at this to classify it as a malaria infected cell and not an uninfected or a normal cell, right? So that is what ML explainability, the gist of it is. And Google Cloud Platform basically now has something that's called Explainable AI. It's something new in Google Cloud, but it's something very, very useful. The features of Explainable AI in GCP are increasing every few months, and it's an active area of research even at Google. So there are two things to it, the model builder and model end user. And both of the people who are building the model can benefit from this as well, and the people who are using the model can benefit from this as well. So for example, if I say, how does explainable AI look for image models? So if I have like an animal detection a recognition model, then this is what explainable AI is giving me as a result. So if it's classified as a bird, so the model is telling me, okay, these are the pixels in your images that basically gave a high signal for this being a bird. So it's identifying, for example, the beak of the bird is giving a high signal, and that's why the model said, okay, this is a bird. In contrast to this, if, for example, I had passed this image and it has said it's not a bird, or it was saying it's a bird and giving high signals of pixels in the background, then I sort of know that my model isn't performing well, even though it's sort of giving the right result. But this acts like as a debug tool to be able to say, okay, it's not performing well in the sense that it's looking at the background pixels and saying, okay, this is a bird. So when I have passed this to, you can work with Explainable AI directly from your Google CoLab as well. There are a few steps, projects, setup steps that you require, where you're authenticating with your GCP, you're creating a bucket, deploying your model, basically all the steps that were shared in the previous, right before I started. So all of those by Mustafa. So all of those steps can sort of be done directly from Google CoLab as well through a few commands, and that's where all of this comes in. But I wouldn't go into the details of that. What I really want to share is that these are my images that I send out to the model, right? And these are infected images, and they're I can sort of see, okay, these are infected, maybe because of these, but I really want to know what my model thinks about this. Why is my model calling these infected, right? So I can pass these on to my explainable AI predictions, right? So I can get predictions, normal predictions, but then you can also get predictions with explanations. So when you say with explanations, you're basically using GCP's explainable AI. And in that case, you can see here that it has sort of highlighted these areas for me, that these are the regions that gave me high signal that, okay, this is infected cell. And same for this case and this case. If I compare these to my images above here, so you can see that these were the areas that were basically correctly saying that these are infected images, right? And my model is kind of like correctly classifying the regions that are causing it to be an infected cell. So that's what this is. Explainable AI is not just for images. It's for both. It's for text. It can be used for tabular. It can be used for images. But the gist of it is uh, to basically give explanations on why the model is performing the way it is performing. So for text models, for example, it'll highlight areas of, so it classified this sentence as an action sentence, and then it has given, highlighted these words that are making the model call it an action sentence, right? And classifying this as an action sentence. So you can use explainable AI not just to improve your model, but also to debug it in ways that you may not otherwise be able to debug. But at the same time, to be also able, and if it is performing well, to be also able to confirm and increase your confidence in, okay, is it really actually performing well, or is there some bug that's causing it to give high accuracy? Right. And especially in cases where you have to pitch ideas to investors and they're always asking, okay, how well is the model doing? How well is it performing? And you want to be able to give them some info of, okay, what is your model really doing, instead of just giving them the result. Okay, this is what accuracy I'm getting, or this is how the results are. But to be able to give more intuition into, okay, why my model is performing the way it is performing, and what is it really lighting into, right? I guess that's about it on my end. And just a little overview of what CoLab does and Explainable AI.
Okay, thank you, Aksa. I guess if people have some of the questions with you to ask with.
Yes, please.
Okay, one of the question is, how is GCP explainable AI different from attention, CAMs and grad CAMs?
So attention is a completely different concept. Uh, that's a concept on the model level, right? So having attention in a model, right? Is that what they're referring to?
Okay.
Uh, so that's something that's related to, if I got it right, I think they mean the attention in models, right? That's on the basis of how you're building the model, and attention is used in with respect to, okay, which feature of your data set you basically want to put more attention to, and that's something that has improved model performance. So it's something with respect to building the model, whereas explainable AI is something with respect to understanding the model. It's not something that's used to build a model in no way, but it is something that is used to understand why the model is performing the way it is performing. And there's a whole theory of Shapley values and game theory. It's actually based on the interesting game theory, and to give you an idea of, okay, why is your model making the predictions, making which pixels is it focusing on when it says, okay, this is a cat or this is a dog, and to be able to debug that model better.
Okay, great. So if I can summarize what Aksa is saying, so Aksa, you can correct me if I'm wrong, that the model should be explainable, and that's what Aksa has told. And when you find the explainability to be on the side that you think that the model is not focusing on the right things, then you can give attention to CAMs and grad CAMs. So you can stress over what model needs to stress upon and what it needs to leave. Similar example works in NLP as well. And if you have a sentence and then you need to get different things out of this sentence, so you need to tell the model what should be in its attention phase and what should not be. So generally, attention is also a great chapter in LS teams as well.
Yeah, so basically, explainable AI is a tool in on GCP, right? That you can integrate with the models that you're deploying on GCP. So, for example, I am deploying this model here on GCP, and I can add explainable AI to this, right? So I will be able to, so I define my, so I've defined where I'm exporting my model in GCP right to the right bucket. And then I am defining the explanation meta, right? This is where what I'm going to send to my explainable AI tool on GCP. So I'm defining what my input layer is and what my output layer is, right? And then I am basically sending, I am defining which kinds of explanations do I want. So there are different kinds that you want. Some are better for text, some are better for images. So there's ID explanations, and then there are XR AI explanations. So I'm defining all of those, right? So my explanation method, for example, here is integrated gradient. So that's one method. And then it could also be XRAI, right? This is a different method that's used for explainable AI, right? And I can define these different methods, and then I can send requests to my models, and I can say, okay, predict for this image, right? For example, right here it's done. So I can say, okay, predict. I can pass the explanation meta file, and then I can say, okay, predict for these images, but also tell me, also give me explanations on each of those images, right? So you're using not just your model deployed in GCP for predictions. You're not just using Google AI Platform, but you're also using the Explainable AI tool on Google Cloud Platform. Let me also give in. I'd also link you to a session that I recently did. The video for it is on YouTube for those who are interested. And I've given more detail into what exactly explainable AI is for each of different images, texts, tabular data, etc. So this is a very nice tool on Google Cloud that can be used. Yeah, that's about it.
Sounds good. Great. Thank you, AQSA, for joining us. And